Let's take a look now at what happens if we have two quadratics that may or may not intersect each other. Y equals 2x squared take 5x take 2, and y equals x squared plus 3x plus 1. It's the same process as before. I can pull this to the right or that to the left, it doesn't really matter. In either case, we're going to get much the same thing. Y equals 2x squared take 5x take 2. Again, it's a quadratic. Again, we have to make one side equal to 0. The simplest way to achieve that is to start removing x squared from each side. 3x plus 1 equals x squared take 5x take 2. Next, I think I'll subtract 3x from each side, so that 1 equals x squared take 8x take 2, and take 1 from each side. 0 equals x squared take 8x take 3. So it's a quadratic equation, and there are three methods available for solving this. The first one you should always consider is factorising. If it factorises, that is going to be the quickest, most efficient way of working through this question. However, this one does not factorise. The other two options are to use the quadratic formula or to complete the square. Generally, I would suggest the quadratic formula. People tend to find completing the square more difficult, but perhaps for that reason here I will complete the square just so you have an example of it working. 0 equals, we now spend a bit of time completing the square. 0 equals x minus 4 all squared is my starting point. Now, if I was to re-expand this, I would get x squared, take 4x, all of that's good because that's my x squared take 8x being produced. But it will also produce a positive 16 from the negative 4 times negative 4. Now, I'll not lose that, minus 3. In here then there is a positive 16 that I do not want, so I have to get rid of it. If you're not sure about that, then you re-expand and make sure that it is in fact equivalent to this. We just tidy that up. 0 equals x minus 4 all squared minus 19. And now the method for solving a quadratic equation by completing the square goes as follows. Add 19 to each side, so that 19 equals x minus 4 all squared. Square root both sides. Keep it as a surd, square root of 19. But as we saw in the last question, don't forget that both the positive and negative versions work. This is why in the quadratic formula there is a plus or minus sign. It's to allow for both of these solutions. Now I shall add 4 to each side, and I've discovered that x is 4 plus or minus root 19. Two solutions. I think because of what comes next, I think I will write them out separately. There we go. Two x values. Now, we need to substitute these back into y equals x squared plus 3x plus 1. And that's, well, rather unpleasant. So what I would advise you to do is the following. Take your calculator and it's not clear enough. There we go. Put in the 4 plus root 19 and press equals. That puts it into the short-term memory. Clear the screen. Now, x squared plus 3x plus 1. Using the answer button brings up the short-term memory, so it's remembering the 4 plus root 19 as I type in that answer button. Even better than that, it's putting it into a bracket. It's looking after everything that needs to be looked after, so I can be confident in this. 48 plus 11 root 19. 48 plus 11 root 19. Go back to the beginning and use the 4 minus root 19. Press equals. Clear the screen if you want to. X squared plus 3x plus 1 equals 48 minus 11 root 19. And so we have the intersections at 4 plus root 19 pairing up with 48 plus 11 root 19 and 4 minus root 19 pairing up with 48 minus 11 root 19. It's rather awkward, but just consider for a moment. If we had done that graphically, if we had taken the time to plot the two quadratics really carefully on a really detailed graph, we would only have been able to read estimates off the graph. They could not possibly be this accurate. This algebraic version gives us a much better answer in terms of just being accurate.